Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
In the intellectual firmament of the late 18th century, few stars burned with the cold, brilliant intensity of Pierre Simon Laplace. His monumental 1798 publication, Exposition du système du Monde, stands as a landmark achievement, a literary and scientific synthesis that defined the cosmos for a generation and articulated a worldview of profound and enduring consequence. This work was the culmination of a century of mathematical progress, a grand narrative that translated the arcane language of celestial mechanics into elegant prose accessible to the educated public of post-revolutionary France. It presented the universe as a majestic, self-regulating clockwork, a system governed by immutable physical laws whose discovery represented the supreme triumph of human reason. The Exposition is a testament to the Enlightenment project, encapsulating its ambition, its confidence, and its definitive vision of a rational and ultimately predictable reality. The genesis of the Exposition lies in the immense shadow cast by Isaac Newton. Newton's Philosophiae Naturalis Principia, Mathematica of 1687 had established the foundational law of universal gravitation, a force proportional to the product of two masses and inversely proportional to the square of the distance between them. This provided a unified explanation for both terrestrial and celestial phenomena, from the fall of an apple to the orbits of the planets. Yet, the Principia left profound questions unanswered. The complex gravitational interactions among the planets, the Moon, and the Sun created perturbations in their orbits. Newton himself expressed doubt about the long-term stability of this intricate system, speculating that periodic divine intervention might be required to correct its accumulating irregularities and prevent cosmic collapse. This theological epilogue to a physical theory provided the central challenge for the mathematicians of the 18th century. Figures like Leonhard Euler, Jean Le Rond de L'Alembert, and Joseph Louis Lagrange developed the powerful analytical tools of calculus and differential equations, transforming Newton's geometric demonstrations into a robust and predictive analytical mechanics. Their immense, technically demanding labour sought to demonstrate that the solar system was, in fact, inherently stable, its apparent irregularities being cyclical and self-correcting. Laplace, a master of this new analysis, dedicated his life's work to this grand problem, the results of which would fill the 5 volumes of his technical masterpiece, the Mécanique Céleste. The Exposition du système du Monde served a different, though equally vital, purpose to present the glorious conclusions of this mathematical quest without recourse to its forbidding formalism, making the new cosmos intelligible. The architecture of the Exposition is a model of rhetorical clarity and logical progression. Across 5 books, Laplace guides the reader from the familiar to the profound. The first book details the apparent motions of the planets, the Sun, and the Moon as seen from Earth, a descriptive astronomy accessible to any observer. The second book elevates the perspective, describing the real motions of these bodies within the heliocentric framework of the solar system. Here, the reader learns of Kepler's laws of planetary motion, understanding the elliptical paths and their properties. The third book introduces the fundamental principles of motion and force, laying the groundwork for a dynamic explanation. It is in the fourth book that the system finds its unifying cause, the theory of universal gravitation. Laplace demonstrates with eloquent certainty how this single law accounts for all the phenomena previously described, from the precession of the equinoxes to the subtle variations in lunar and planetary orbits. He presents the results of decades of complex calculations as settled facts, assuring his audience that the solar system is a stable, permanent structure, its intricate dance guaranteed to continue for eons. The entire edifice is constructed without a single equation, a deliberate choice that transforms a mathematical treatise into a piece of persuasive literature, a proclamation of cosmic. The fifth and final book of the Exposition presents its most original and speculative contribution, the Nebular hypothesis. In this sweeping historical summary of astronomy, culminating in his own theory, Laplace proposed a naturalistic origin for the solar system. He posited that the Sun and planets formed from a vast, slowly rotating, and extremely hot cloud of primordial gas, and nebula. As this nebula cooled, it contracted under its own gravity. The law of conservation of angular momentum dictated that as the cloud shrank, its speed of rotation would increase. This acceleration caused the nebula to flatten into a disk, and at its equator, centrifugal force would eventually overcome gravitational attraction, causing successive rings of gaseous material to be shed. Each of these rings, he argued, subsequently cooled and coalesced under its own gravity to form a planet, with the moons forming through a similar process on a smaller scale round their parent planets. This hypothesis, likely developed independent of Immanuel Kant's similar but less physically grounded proposal from 1755, was revolutionary. It provided a coherent, evolutionary account of the solar system's formation from a simple initial state, governed entirely by the known laws of physics. The neat architecture of the solar system's coplanar orbits, the common direction of revolution and rotation arrows as a natural consequence of its formation. This physical cosmogony carried immense philosophical weight. The universe of the Exposition is a deterministic and causally closed system. The intricate stability and ordered genesis of the solar system required no supernatural guidance or intervention. This perspective is famously captured in an exchange, perhaps apocryphal yet perfectly illustrative, between Laplace and Napoleon Bonaparte. Upon being presented with the work, the first consul allegedly remarked on the absence of the creator in this vast celestial mechanism, to which Laplace is said to have replied, "Sire, I have no need of that hypothesis." This statement, whether uttered or merely attributed, encapsulates the intellectual spirit of the book. The success of celestial mechanics implied a universe where every effect followed from a prior cause, governed by mathematical laws. The concept of Laplace's demon arises from this worldview, a hypothetical vast intellect that, knowing the precise location and momentum of every particle in the universe at a given instant, could use the laws of physics to calculate the entire course of cosmic history, past and future. The universe, in this view, is a grand trajectory, its entire state at any moment completely determined by its state at any other. The Exposition was the public manifesto of this deterministic philosophy, a vision of reality as knowable, predictable, and self-sufficient. The legacy of the Exposition du système du monde was immediate and far-reaching. It became the definitive popular authority on the cosmos for the 19th century, shaping the worldview of scientists, philosophers, and the educated public alike. Its secular and deterministic outlook provided intellectual fuel for the positivist philosophy of Auguste Comte and reinforced the growing current of scientific materialism. The nebular hypothesis, in particular, dominated cosmological thinking for over a century, serving as the default model for the origin of stars and planets, while subsequent discoveries revealed complexities it could address, such as the anomalous distribution of angular momentum in our solar system. Its core concept of gravitational collapse from a rotating cloud remains a central feature of modern astrophysical theory. The Laplacian vision of a clockwork universe, however, faced a more fundamental challenge: the rise of thermodynamics in the mid-19th century, with its concept of entropy and the irreversible arrow of time, introduced a narrative of decay that sat uneasily with the idea of a perfect, eternal machine. The true revolution arrived in the early 20th century with the development of quantum mechanics. The inherent probabilistic nature of reality at the subatomic level, encapsulated in Werner Heisenberg's uncertainty principle, dealt a decisive blow to the classical determinism that Laplace had so confidently championed. The cosmos was revealed to be a place of intrinsic uncertainty and chance, a reality where Laplace's demon would forever lack the complete information required for its calculations. In conclusion, Pierre Simon Laplace's Exposition du système du monde represents far more than a simple popularization of astronomy. It is a defining document of the Enlightenment, a monument to the power of reason and analytical thought. With majestic prose and unshakable confidence, Laplace presented a vision of the universe as a perfectly ordered, self-contained, and comprehensible system, born from natural processes and governed by eternal laws. It synthesized a century of ferocious mathematical effort, closing the chapter opened by Newton and offering a definitive, secular answer to the question of cosmic stability, while the relentless march of science has since unveiled a universe more complex, more chaotic and more uncertain than the one he described. The Exposition retains its historical power. It stands as the ultimate expression of the classical mechanical worldview, an intellectual peak for which the universe seemed, for a glorious moment, to be entirely solved. The work's ambition to construct a complete and rational system of the world remains a powerful inspiration, a testament to the unending human quest to comprehend the cosmos and our place within it.
We really appreciate you tuning in to this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.